In this session, let's learn about Oracle 11G. You are thinking, what is G? G stands for grid. Yes, Oracle tagged the Oracle database version with letter G because it supports grid computing. Now you are thinking, what is grid computing? Grid computing is a way of organizing the computer resources such a way that they can be flexible and dynamically allocated. Okay, you see, in this diagram we have four servers and there are several users connecting to the server. If we have only one server, then all the load will be on that server, right? And obviously the performance will be degraded. But if you have multiple servers, you can support a huge number of users, and also since the load is shared by all the servers, the performance will be good, right? Yes, another advantage is even though we lose couple of servers, that's fine. Still, we have two more servers which can help the users, right? So, in grid computing, we can have multiple processors or multiple storage devices or multiple databases or multiple application servers so that even if one fails, we have another one, and also these can serve huge number of users. Okay, that's the basic concept of a grid computing. So Oracle took that grid computing concepts and applied to the Oracle database. Let's see how they applied those grid computing concepts. If you look at the architecture, Oracle provided the option of maintaining multiple database servers. Maintaining multiple database servers is referred as real application clusters or RAC. Okay, in the real application clusters, you have a bunch of database servers where the load is evenly distributed among the users. Even if you have thousands of users requesting database access, the load is evenly distributed on the database server so that there are no performance problems, and also for high availability. Even if we lose couple of data servers, we have the other database servers up and running and serving the users. Okay, that is the concept of a real application clusters. Now they said, okay, that's fine. By having multiple database servers, we can avoid failure and distribute the load. But what if the disks fail? That's a good question, right? Yes. So they said, why don't we replicate the data into multiple disks? And they came up with the concept of automatic storage management, which is referred as ASM. In the ASM model, the data in the files are stored in the disk groups and are evenly distributed to provide uniform performance across the disk. Think about it. If all the data is stored in one disk, then the processor have to read from that one single disk and the performance will go down. Instead of that, if the data is replicated among all the disks, then instead of competing for one disk, the database servers can read the data from the multiple disk groups, right? Yes. And the another advantage of using automatic storage management is we can mirror the files. That means we can maintain multiple copies of the same files. Yes, we can maintain multiple copies of the same files so that even if we lose one copy, we will have another copy for the database to run without any failure. Okay? The other advantage of using the automatic storage management is you can add and remove disks from the disk group while the database is still up and running. Yes, you can add or remove disks while the database is still running. Cool, right? Yes, all these features of grid computing make Oracle say that they support grid computing. That is why they said Oracle 11G. G means grid. Okay.